Well, hello everyone, my name is Andrew Howard, I am the CyberIrishman, and here's my lecture on DNS. Everything you're going to need to know if you're doing a CISSP, a CH, or a Security Plus. We're going to talk about how it works, and we're also going to demonstrate some of the hacking involved. So let's get going. So here's what we're going to cover in the course. We're going to talk about DNS, its structure, and how it works. What is the DNS cache on your computer and how does it work? Let's take a look. We're going to talk about DNS security and why we need it. We'll talk about two different types of attacks. An attack on the DNS server itself and then an attack on your machine, sometimes called a man-in-the-browser attack. We'll talk about evil twins and rogue access point attacks. Now these are wireless attacks, but we'll see how DNS can be a problem there as well. Now DNS security is security used from the DNS server upwards towards the DNS architecture. As a normal person, a user, there's nothing you can do about that. However, we will talk about some of the secure DNS implementations you can make as a user. We're going to talk about DoH and DOT. That's DNS over HTTPS and DNS over TLS. Now, if you're taking a CES or you're taking a Security Plus or even a CISSP, they're going to talk about zone transfers. So we'll explain what it is and how you might do an attack. We'll even do a demonstration. Now, if you're doing CH, you're specifically going to want to know how you might brute force subdomains on a DNS server. Those IP addresses can be a great place to do an attack, and we'll demonstrate how you might do it and we'll explain why it's so powerful. Now we'll talk briefly about another attack called a homograph attack, and that's where we use special characters or characters from different character sets that look like Latin characters to disguise the real identity of a website. It is a great thing for an attacker if they're trying to do a phishing attack. And then to round things off, we're going to talk about DKIM and SPF. Now this is part of email security, but it relies on the DNS system to make it all work, and we'll discuss that in detail as well. So if you're ready, let's get started. So let's start talking about the DNS system. This diagram looks complicated at the beginning, but don't worry, I'm going to explain everything to you. Now at the top you can see we have what's called the root of the DNS system. These are the really top players. They're the ones that control the whole DNS system. And as you can see, there are 13 servers. There are actually 13 logical servers. There are many other virtual servers and distributed servers as well, but 13 companies or organizations that control DNS. You can see VeriSign is one of the companies, a well-known certificate authority, and then ICANN as well, who gives out IP addresses. Now these are the gatekeepers, the ultimate authority for DNS. Just below, you can see we have what's called the TLDs. These are the TLDs, the .coms, the .nets, the .edus, the .orgs. Now each of these TLDs, like a .com, is controlled by an organization or company. For instance, VeriSign, a very famous certification authority, they control the .coms and also the .nets and the .edus. Now there are other TLDs as well, like .org as we can see, and .ie. .e is Ireland, and that's controlled by the Irish Domain Registry. Now they're the ones who will register a TLD for you. Now who is going to sell you an actual domain name if you want one, for instance CyberIrishman.com? It's going to be a registrar, somebody like GoDaddy, and as you can see, that is the third layer we have down here. Now this is somewhat simplified, but it's good enough for us. So when I want a domain like CyberIrishman.com, I'll go to GoDaddy and they will sell me CyberIrishman.com. They will then let the internet know what IP address is linked to that domain name, and they do that with their name servers. I register with GoDaddy, and then on GoDaddy's name servers, and they will have multiple for redundancy, they will have a DNS record that links CyberIrishman.com to the IP address of my server. I can rent a server from GoDaddy, or I can rent it from any one of a number of different companies, or I can host it myself on Amazon Web Services. Okay, so this is how it should work if everything's working correct. I'm down here, I'm the client, and I want to know the IP address for somebody like bestbuy.com. I type that into my browser. Well, the first thing that happens is my client, my laptop, will send a request to its DNS server. That might be my ISP's DNS server. It might be a corporate DNS server if I'm working inside a corporation, or it might be somebody like Google or 1.1.1.1. It just depends. Comcast, for instance, have their own DNS servers. Now, if somebody has looked for that IP address from that DNS name recently, it will be cached in the DNS server. If it is, it will just reply back to me and give me the IP address I'm looking for. However, if it doesn't know, it has to go into the DNS system and find out for me. So what it's going to do is it's going to go first to the root server, one of the root servers. And it's going to say, hey, I need the IP address for bestbuy.com. The root server is going to say you need to ask the .coms, and it will redirect us to the top level domain for .com, which in this case is VeriSign. So we're going to ask VeriSign, hey, what's the IP address for bestbuy.com? Well, VeriSign is going to say, hey, I know GoDaddy sold that domain, so you better go and ask them. So we're going to go to GoDaddy, and we're going to go to their name servers. And we're going to ask their name servers, which are DNS servers, hey, what is the IP address for bestbuy.com? And if everything is working well, it replies bestbuy.com, gives us the IP address. The DNS server remembers it, or the term we use is caches that result. And then it responds to us with the IP address we need. And then we go to the server, bestbuy.com, and we do our transaction. That's how it should work. Now, when it works well, it works great. But when it doesn't work, when something goes wrong, then we have problems. And we're going to talk about the attacks that can happen around this DNS system. Now, if we want to go ahead and look up the IP address of a domain ourselves manually, we can do it. The two commands we're most likely going to see are nslookup and dig. nslookup is on Windows and Linux, and dig is only on Linux. And we're just going to do a lookup, as we can see here, nslookup, bestbuy.com, and it replies back with the IP address of Best Buy. Now, alternatively, if we're using any Linux system, we can use the command dig. And when we use the dig command, we do basically the same thing, dig bestbuy.com, and we're going to get an answer, and we can see it down here, exactly the same result. Now, we'll talk more about dig later. It's actually more powerful than just doing lookups of IP addresses. Let's talk about caches on our computer. If we've recently looked up a domain like bestbuy.com, our computer is going to remember that IP address for a while, just in case we go back there in a short period of time. Now, it can be stored in different places on our computer. It can be stored in our browser. If we use a particular browser to go to a website, our browser will remember. And that is the first place our computer will look. If we type in bestbuy.com in a browser, it'll check the browser first. If it doesn't find the IP address in the browser, it's going to talk to a file called a host file. This is a hard-coded file on our computer and actually can be a vector for an attack. This should not be modified generally by the user, but if an attacker can get into that computer and change that host file, they can give a fake IP address for a domain. So when we type amazon.com into our computer, we don't actually go to the IP address of amazon.com, we can go straight to a phishing site. Now, the third place it's going to look is in our OS Resolver cache, and we're going to show you an example of that OS Resolver cache on Windows. Our Windows operating system remembers also. And then if that doesn't work, the last thing that will happen is our operating system will go ahead and look up that IP address for us. It'll go through the sequence I showed you previously. Go to the DNS server, the DNS server will go and check on the internet, and we'll get our result. Alright, so speaking about the host file, let's take a look at it. I have opened up an administrator command prompt on my Windows machine. See if I can make this text a little bit bigger. Yeah, I can. Excellent. A little bit bigger here. And what I'm going to do is I'm going to use the command type, because I'm in the correct directory. Sorry, it's a little bit awkward for me to have to type here. And we're going to open the hosts file. Type hosts. This is the host file on my machine. Again, we're in Windows System 32 drivers, etc. And this is a sample host file. It is the actual host file. What I can see here is everything has been commented out. The hash comments everything out. But if I was an attacker and I got access to this host file, what I could do is something like this. This is what a DNS man in the browser attack would look like. As you can see, I've hard-coded this IP address 32.3.2.1 to google.com. And if that's in the host file and it's not commented out, if my computer's browser did not have a cached IP address for google.com, for instance, I hadn't been there for a couple of days, it would go to this host file and it would go to that IP address. And if I wasn't paying attention, if I didn't check that the padlock looked good, if I didn't notice there was no certificate, I might be dragged in, type in my credentials, and off we go. I've been phished. So that is the host file. Next, let's talk about the OS resolver cache and flushing that cache on our machine. So we can display the cached results of the DNS searches on our computer. Let's go ahead and do that. ipconfig display DNS. Let's give it a go. Look at all the stuff here. These are all the websites that I have visited recently. So a bunch of stuff there from Microsoft. What else do we have? That's my own home computer that I'm talking on. There's some IP version 6 addresses there. Microsoft again. Game Pass, Akamai. All kinds of stuff. Excellent. So these are the websites my computer, really services of my computer have gone to recently. Now, even 3 or 4 years ago, that would have been much fuller because all my browser requests would have been sent to that resolver in the OS. But now, most of the browsers do their own DNS lookups themselves internally. Now, just a quick note here, Linux doesn't have exactly the same thing going on. There are different services in Linux that can do it, depending on how your machine is configured. So I just demonstrate it on a Windows machine. So let's do a lab. Let's talk about what we're doing here. We're going to display the DNS cache. ipconfig, display DNS. Perfect. Get my Opera browser ready. What else do we want to do? We want to flush the cache, so we're going to use the command flush DNS. Let's do it. ipconfig flush DNS. That's going to delete everything in the DNS cache. And if we go back and we now display the DNS, there's going to be a lot less in there, only 3, because Windows and Microsoft were immediately going looking for more stuff, right? But we've gone from 30 or so different entries to only 2 entries in our DNS cache. So that can work. If we're trying to hide our tracks, this is something we may want to do. Now let's do an nslookup. Let's go and look up bestbuy.com. And we're going to go ahead and we're going to find the IP address of bestbuy.com. It's got it first, 184.29.20.246. Excellent. Oh, Windows, you try to be helpful, but you never are. You just never are helpful, Windows. Oh my goodness. Killing me. All right, no problem. Let's go ahead. We've looked up the IP address for Best Buy. Let's now go ahead and look up our DNS cache and see if it's in there. A lot more stuff all of a sudden has got in there. But let's see, we've got Adobe spying on us in the background. Another IP address. docs.live.net, that's Microsoft again. Docs.live. IP version 6 address. We've got some MSN, Microsoft again, but nothing for Best Buy. In this case, what happened is nslookup uses its own system tools to do the nslookup. It doesn't use on the primary resolver in the operating system to do it. Alright, let's flush that DNS again just to make things nice and quiet for us. We're going to do a flush DNS one more time. Excellent. Let's go ahead and look up Best Buy on our computer. We're going to go to bestbuy.com, and in the background something is going to look up the IP address for bestbuy.com. Now I'm using the Opera browser. We've got bestbuy.com. Surely we're going to find that in the DNS cache of the operating system. And as we look through here, we got Cloudflare, we got Google APIs, MSN again, thank God for MSN, and that's about it. Opera, auto update. As soon as I opened Opera, it went and checked to see if it needed to update, but nothing for Best Buy. And that is because most modern browsers actually do their own DNS lookup. One more lab. Let's try one more time. Let's ping bestbuy.com. Now when we ping bestbuy.com, that service does actually ask the OS to do the lookup for us. So now when we go to display DNS, hopefully we're going to find, Game Pass is in there. Bestbuy.com, now it's in there. Excellent. So what have we learned? We've learned most modern browsers, they do their own DNS lookup. Only services that are asking the operating system to do that DNS lookup, that don't have an inbuilt service, only then will we see it in the OS's cache. Now, non-recursive lookups are very popular on exams. What is a non-recursive lookup? We're telling our DNS server, hey, I need to know the IP address of this domain. If you know it, tell me. If you don't know it, then don't do anything. That way we know if somebody has looked it up previously in the last 24 hours and it's in the cache, we'll get the result. If nobody's looked up that particular domain in the last 24 hours, it will not be in the cache. The DNS server will not go to the internet and try and find the IP address for us. It can be very useful when we're doing forensics. If we do find it in there, we know somebody on our domain has looked up that domain name and got the IP address. We don't know who did it. For that, we're going to have to go to the DNS server and look at the logs. That is an exam favorite question. And here's two of the ways we may do it. Dig, specify the DNS server and then the domain name, or we can use nslookup as well. We're going to talk about DNS attacks. We're going to talk about a DNS poisoning attack and how we defend against that using something called DNS security. One more time, let's go over how DNS should work. The client wants to know the IP address of bestbuy.com. It goes to its DNS server, ISP, corporate, Google, whoever. If the server knows, it tells us. If it doesn't know, then it goes out to the DNS system on the internet, asks the root. The root will redirect us to the appropriate top level domain, in this case a .com, VeriSign. VeriSign will know who registered that domain name, bestbuy.com, and send us to the registrar. For instance, GoDaddy. GoDaddy will point us to its DNS servers, its name servers. Now, later we'll talk about an SOA, a source of authority. One of those name servers is the king. It's the one we manually update, and the updates get propagated to the other name servers, in this case controlled by GoDaddy. One of those name servers will reply back to the DNS server we're using with the result, and the DNS server will send the result to us, the client. That's how it should work. What could possibly go wrong? So the attack we're going to talk about is DNS cache poisoning. This is another very popular exam topic. And how does it work? As before, my client is asking for an IP address for a domain, bestbuy.com. In this case, it is not already cached in my browser. It is not already cached in my host file. which it shouldn't be, and it's not cached in the resolver in the operating system. So off we go and we ask a DNS server, what is the IP address for this particular domain? Now it sends a request to the internet. It sends it to the root system of DNS. And the normal sequence should start. It should go down to TLD, it should go down to the registrar, and the registrar should reply to us. However, in this case, the attacker is able to listen to our request, perhaps by taking over one of the routers on the internet on the way to the DNS system. Now the attackers heard our request. Now what should happen is the normal chain of events. But what happens instead is the attacker replies back to us more quickly. And in normal DNS, the first person to reply is the answer we trust. Even if the real answer comes later, it's ignored because we take the first answer we get, and now we have the wrong IP address for bestbuy.com. Instead of having 23.198.241.2, if that's what it is, we have 4.5.6.7. And guess what? This hacker has some kind of phishing website ready to go with that IP address to take our credentials and possibly our credit card number. This is one of the ways we can carry out a phishing attack. Now another way for a phishing attack is just to have a link in the email that takes us to a fake IP address. No weaponization of the DNS system is required in that case. That's why you should never, ever, 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 ever click on a link before very carefully inspecting it if you know how to do so. If you don't know how to do so, just don't do it. So, how do we defend ourselves? Well, we're going to use something called DNS security. Now, DNS security is done from the DNS server up. It has nothing to do with the client. As a client, as the end party, I have nothing to do with this. I cannot specify it. Whoever is running our DNS server, whether it be our ISP or our corporate IT group, they have to set this up. And basically what they're going to do is load in a bunch of certificates and public keys of trusted DNS servers. And they will only trust a reply if that DNS response is signed by somebody who's trusted. Now there's a thing called root of trust where one person can sign a cert for another person who can sign a cert for another person, so they don't have to be completely separate certificates. This is just easier to explain, that we're going to have all the trusted servers have a certificate we trust. We're not going to go into how that is done, but in reality it's done with a thing called a root of trust. So in this case, we go to our trusted DNS server. It has a bunch of public keys and certificates preloaded on it for replies that can be trusted. If it's not signed with one of these certificates, it's ignored. Goes out, does our normal DNS process. It gets down to GoDaddy. GoDaddy replies with a signed response. Our DNS server accepts that response and then sends it back to us and updates its own cache records. That's how DNS security works. Now, as end users, as clients, what can we do to secure our DNS traffic? Well, we can use two systems that are commonly out there that are very effective: DoH and DOT. Now, DoH is DNS over HTTPS and DOT is DNS over TLS, and they're both fairly similar. They build a tunnel around our DNS traffic. It's sent via TCP rather than UDP 53 for normal DNS. So we build a tunnel. Our traffic going to that DNS server is encrypted. Nobody, including our ISP, can see what domains we're asking for. So it keeps at least what we're searching for private. However, if we just go to that website next, our ISP knows we went to that website. So how secure is it? It's not particularly. However, let's get back to it. DoH, very common exam question. It's DNS over HTTPS secure. It uses port 443, just like normal HTTPS. It's implemented in most modern browsers by default, and you can turn it on and turn it off if you want. We can also specify in our operating system to use DoH as well. Now, a particular example of an implementation of DoH is Oblivious DoH, and that's been created by Apple to give us even more privacy. In Oblivious DoH, we send our request to a proxy hosted by Apple. Apple allegedly doesn't remember who asked the question. The proxy goes and does the DNS request for us, gets back the response, and then sends it to us. All the time not really remembering, at least long term, who we were looking up. So this is like NordVPN for DNS. You can implement it on iPhones, iPads. You need to go to your settings, Apple ID, cloud, and use the term turn on private relay. And then you'll be good to go. So it's a pretty good privacy step. Now, the other one we might see on an exam is DOT, DNS over TLS. It uses a different port, 852, very, very similar to DOH, just uses a different port number. And that is turned on by default on most Android operating systems, DOH and DOT. Now, how do we turn on DOH in Windows? Well, we can do it at the OS level. So instead of our computer looking up on UDP port 53 and everyone being able to look at that traffic, we can go to settings. We go to the Wi-Fi or the network card that we're using, the connection that's active, and we want to edit our network settings. And here we can go in and we can turn on our DNS over HTTPS. We turn it on. By default, this is the profile or the template used, Cloudflare, which is the common profile or template, but we're setting our DNS server not to Cloudflare. Here I've set it to 1.1.1.1. That's just the DNS provider I like to use. And here's our alternative DNS server. In case 1.1.1.1 goes down, we have 1.0.0.1, which is also just a backup IP address for 1.1.1.1. And that's how you turn it on your Windows computer. So this is something you do have control over. You can set it in your browser, just for that browser, and you can set it at the operating system as well. So let's talk about some of the other records we're going to find in our DNS file for our domain. Now, normally you're going to have an A record, which is your IP version 4 address. You need that. You may also have an IP version 6 address, also called the AAAA or quadruple A record. We're going to have a record for the start of authority, sometimes I call it source of authority, and this is in our registrar. We have multiple name servers, multiple DNS servers. One of them is going to be the top dog. That's going to be the one that our admins go into, update the records, and those records then are propagated to the other name servers in the group for somebody like GoDaddy. And the other servers are called name servers. Now, if that domain also has email, most do, we're going to list the IP address of the mail service we're using. For instance, I use Zoho. So my MX records for CyberIrishman.com point to Zoho.com. There's also a CNAME, a canonical name, and a canonical name is kind of like a pet name. What it's saying is if you see a request for this name, here's where you actually want to go. And a very common one of those is www.whatever domain. We don't normally type in the www anymore, but it is a subdomain of a domain. So if somebody goes ahead and types it in, we can redirect them to just that domain. So if somebody typed in www.cyberirishman.com, then they will be redirected to cyberirishman.com. And then there's one other very important field. It's called the text. Now the text is open standard. It's kind of free flowing what you can put in there. But this is where you're going to find your DKIM and your SPF for spam prevention on email. And we're going to talk about that at the end of this particular lecture. So let's go ahead and look at what a DNS record actually looks like. So here is a domain. I've modified this a little bit, but this is likely what we're going to see. So here we have a domain called everreadyguides.com, right? And this is what the DNS record would look like for a domain. Now our source of authority record is telling us which of the name servers at, in this case, GoDaddy, has the most complete up-to-date record if we need to know up to the second what is the absolute definitive record for this domain. We can go to this name server, ns01domaincontrol.com. Now let's look at the A records, which are IP version 4 records. At means for this domain, so for everreadyguides.com, this is the IP address, 173.254.23.40. But wait, we've got some subdomains in here as well. Vendor login is at a different IP address, vendorlogin.everreadyguides.com. And then FTP, if we had an FTP server, FTP is at even another IP address. So the subdomains are listed under the A records and the quadruple A records if we have them for those subdomains. Very interesting. This information can be very useful to a hacker because the main website is usually very well protected. .40 is probably well protected. But the vendor login might be some kind of VPN device that hasn't been updated. Who's still using FTP? That server's got to be really old. Those are the two servers I, as an ethical hacker, am going to try and break into. So all these subdomains are very, very juicy information. And we're going to talk about how we brute force those a little bit later in the lecture. Now here's some CNAME records. We have shop. So shop.everreadyguides.com is going to redirect us to everreadyguides.shopify.com. Yes, Shopify are going to be hosting our online shop. And then we have that other one, www, which is a common CNAME for everreadyguides.com. If we type in www.everreadyguides.com, it will just take us to everreadyguides.com, which is at this IP address up here, 173.254.23.40. Then we have our MX records. If I want to send email to everreadyguides.com, who do I send it to? Zoho.com, one of these mail servers. And also, if somebody is sending us email from everreadyguides.com, it should originate from one of these servers as well. This is part of the spam protection. Now the other part of this is our TX records. It holds this information. The first is the SPF, includes Zoho.com all. The SPF says if somebody's purporting to be everreadyguides.com, it should come from a server, Zoho.com. That's where it should come from. If it's coming from Gmail or somebody else, it's spam. Ignore it. And then we have this thing called a DKIM. And a DKIM is the public key for the Zoho server that my email would be sent from. So when somebody receives email from everreadyguides.com, if they're set up for spam protection, that receiving email server is going to go to the DNS records, go to these records, look up this SPF information and look up the DKIM information. It's going to make sure that that email came from Zoho.com, and it's going to look for a signature, and that signature should be signed with this key, this public key that is shown here starting with MIGF. That public key should decrypt the digital signature of that email. And if neither of those steps are good, then it's probably spam. And then at the very bottom you can see the NS records. These are the other servers. This is the group of name servers owned by GoDaddy. And in this case there's only two, NS01 and NS02. And we already know that NS01 is the source of authority. Not all domains do it exactly this way. Sometimes the NS records will be the public facing servers, and the source of authority will be a completely different server that we don't normally go to as customers looking up DNS records. Alright, let's talk about some attacks then and demonstrate some attacks. We're going to talk about zone transfer attacks, and we're also going to talk about subdomain brute forcing using a word list. Do you have this subdomain? Do you have this subdomain? Do you have this subdomain? Let's go ahead and talk about them. So we've talked about SOA. That is the top dog in the DNS servers, the NS servers for a particular registrar. Now, when we go to a DNS server, we only get the IP address we ask for. So if we ask for google.com, we get the IP address of google.com. We don't get any of the subdomains. You have to know the name of the subdomain to ask for that IP address. Many subdomains are hidden. They're in the DNS records if you know how to ask for them, but you can ask the DNS servers to say, hey, give me everything you have on google.com. It doesn't work that way. So for instance, google.com might have hiddenportal.google.com. That could be maybe a less secure login page for vendors, maybe a VPN device that hasn't been updated, or something like staging1.google.com. That might be a staging server where they test code or test new deployments, and it might be on an old server or a forgotten server or an unpatched server because it's not meant for the public. Now, if we can find these hidden subdomains, we have a better chance at doing an ethical hack on that website or doing a penetration test. So let's talk about zone transfer attacks. A zone transfer attack is when I go to that SOA and I say, hey, I'm one of the other name servers, I'm one of your buddies. Go ahead and give me all your records so I can update my files. When we do a zone transfer, we don't have to ask for all the subdomains individually. We just say, give me everything you have on google.com. And if I can convince the SOA that I'm a trusted server, then I can get all the records for that domain and I can have at it. Now, one of the first steps usually is figuring out which of those servers is the source of authority. And there's a couple of ways we can do it. We can use nslookup. I'm showing you here on screen how to do it. Type ns CyberIrishman.com and it shows us our two different name servers. And now I'm going to go type is SOA. Tell me the source of authority for CyberIrishman.com. And it goes and it tells me it's ns53 domaincontrol.com. That's the server I need to do a zone transfer and attack on. I can't do it on the other NS servers. The SOA server propagates its records to the other NS servers. This is the target of a zone transfer attack, very popular on every exam I teach. So, zone transfer, we pretend to be another NS server asking to update our records. We ask the SOA, and if the SOA is not properly secured, if there isn't ACLs, access control lists, to say only give that information to these IP address, if there's not further authentication, and the thing coming to my mind here is zero trust. If those defenses have not been set up correctly, the server will just give those zone transfer records out. This would honestly be very, very poor management of a DNS server, of a name server, of an SOA. So it's very unlikely to be successful. Hey, but you never know. So we point directly at the SOA and ask for all its records. Now on any exam question, you're probably going to see this flag AXFR. That just means a zone transfer request. So here's what it might look like using the dig command. Dig. I specify the SOA, not any name server, for the domain, and I'm asking for an AXFR record. You can do it using the host command as well on Linux. Looks a little bit different. It's the -L flag there. And you can do it using nslookup on Windows or Linux. Query equals AXFR. Again, you have to specify the source of authority. Which one of the name servers are we talking to? And then very popular with our CH Certified Ethical Hacker are DNS Enum and DNS Recon. Also, GoBuster is another good tool for doing this. Again, these should not work, but it is an exam favorite. So Zone Transfer Me is a domain set up for students. You can actually go at it here and test a zone transfer request. But before we do that, let's go ahead and try it against secureninja.com. Now, as you guys probably know, I work extensively with secureninja.com as well as my own consulting company, CyberIrishman.com. I do have permission to do this test against secureninja.com. So I'm going to do an nslookup, type source of authority, against secureninja.com. Let's go ahead and run that. It gives us back some results. Yep. The dolly.ns.cloudflare.com. That's the one we want. That's the one we want. So let's go ahead now. And we're going to do a DNS enum. This is a tool in ParrotOS, in Kali Linux. You can download it onto any Linux distribution. And this is a very powerful DNS enumeration tool used by hackers and penetration testers as well. And we're going to go look at that particular server, and we're going to do a AXFR request. Now the thing is with DNS enum, it doesn't matter what flags you tend to put in there, it generally does everything anyway. It's going to do a brute force attack against subdomains as well as trying to do a zone transfer attack. So let's let this run. It doesn't always work exactly as expected. So we've got some IP version 4 addresses for secureninja.com, A records. There we go. The name servers, Dolly and Walt. The DNS is being run by Cloudflare. And what we're going to try and do is a zone transfer, and it failed, as well it should. And then it's also going to do a brute force attack. It has a file called dns.txt with some very popular subdomain names, like portal, like shop, that kind of thing, like login, like vendor login. And it's going to test those to see if we get a result back from the DNS server. It's using the word list, dns.txt, and it's going to do a brute force attack against the DNS server. Do you have portal.secureninja.com? Oh, yes, I do. Here's the IP address. Goes through its list of different subdomains and tries each one of them one at a time. Let's let that run for a few seconds. Well, it looks like it's found one at least, autodiscover.secureninja.com. It will find more probably, but just whilst we're waiting for that, I talked about this word list, dns.txt. Let's go to that directory there, user share DNS enum specified. This is the default word list being used by DNS enum. And let's cat that out. Let's have a look and see what's in there. DNS, what is it called again? DNS text. It is called dns.txt. We can cat that out. We can display the contents of that file. And these are all the subdomains it's looking for. www, www2, survey, student, social economic, server X, secure, secure2, princess, polite, mediator, all these different subdomains. It's going to brute force each one of those. I wonder how many's in there. We can actually check. Let's do a word count and see how many words are in there. Let's do a word count. Lines dns.txt. 1,505 different words that we're going to try. Looks like we're still trying. Alright, well that took a moment, and as we can see, our zone transfer absolutely failed. However, we did find some subdomains using that dictionary list, that word list of possible subdomains. So we found 4 there. Well, 3. Autodiscover, Portal, and www. It did some other work as well, tried to figure out what ranges Secure Ninja has, and we have IP addresses in those ranges. So, pretty good. Now, this particular demonstration was about zone transfers, and as expected, it completely failed. However, there is a DNS server set up specifically by some kind soul that allows us to test a zone transfer to see if we can make it work. And that zone, anyone is free to use any kind of a hacking tool or penetration tool just to test their skills. It's called zonetransfer.me. And if we go and we use a tool like DNS enum, and we go to zonetransfer.me, it will actually do a zone transfer. It'll show us some of the name servers for that domain, and it will give us a bunch of information, a whole bunch of stuff that's in the DNS records for that particular domain name. So why don't we give that a go and see if it still works. Zonetransfer.me. So let's go to DNS zonetransfer.me and give that a go. Straight away, got the whole thing, no problem at all. Let's see what it looked like. So we ran our command DNS zonetransfer.me. It found the name servers. The actual domain we're looking at is zonetransfer.me. It found some mail servers. Looks like Gmail, Google, is the people that look after the email for this particular domain. And then it tried to get zone transfers. And look at all the stuff I got. Fantastic. So we have a whole bunch of information in there. Stuff that we wouldn't normally be able to get. And as I look through there, is there anything that kind of interests me? Yeah. Zonetransfer.me. That might be an old VPN server. That might be hackable. That might be interesting. We have a www.zonetransfer.me. That might be useful, an old one as well. A testing subdomain, which actually is a CNAME, and it will actually take us to www.zonetransfer.me. They have a staging, which actually goes on to www.sydneyoperahouse.com. So maybe this particular developer was producing a website for sydneyoperahouse.com. Interesting. Anything else here? I see IP version 6 Act now. So we have an IP version 6 address. Some internal servers that have IP version 4 public IP address. Interesting. And an office server that has an internal IP address. An internal server that has a public IP address. Okay, here's the name servers. The internal name servers. Email, IP address, one of the many. DC office, so there's an IP address for the DC office. Here's the Canberra office's IP address. They're the external name servers. That's probably the primary IP address. So yeah, some pretty good information. So there is a website. If you want to practice your skills, go ahead and check it out. It's a very good example. Awesome. So that was our zone transfer, successful at the very end, because that DNS server zonetransfer.me has not been set up with security. And you'll notice previous to that, when we went to secureninja.com, we also did some subdomain brute forcing. Let's go back to the subdomain brute forcing. So once again, what are we doing here? You cannot see the IP address of a subdomain unless you know the name of the subdomain, right? Unless you do a zone transfer. Now, there's going to be subdomains with old, forgotten, unpatched servers perhaps. And those are the ones, myself as an ethical hacker, as a pen tester, those are the ones I'm going to put most of my attention. That's the most likely place I'm going to be able to break into a network. How do we brute force these subdomains? We use a word list, as I previously showed you. And there's many out there. The one I showed you is pretty small, 1,500 words. There is word lists with a million different subdomain names. Those take a very long time to run. Many of the subdomain brute forcing tools will also uncover the IP blocks. Yes, they may also say, by the way, google.com, its website is at this IP address, but it bought a block of 256 IP addresses. Why don't you try those ones as well, right? Because often we don't buy one IP address at a time, we'll buy multiple, and we'll put our subdomains and our staging servers on those other IP addresses. So there's another way to possibly find a way into a network using the blocks of IP addresses that somebody has purchased and trying those IP addresses. Now, DNS enum, I've run it against google.com, kind of, and I got a bunch of information back. So the enum is basically throwing the flag enum, basically throws the flag at that particular domain. And it got me a whole bunch of subdomains, it got me some IP blocks, and obviously it wasn't able to do zone transfer. But these other IP addresses, these might be useful. I'll try every one of those as well. I'll scan them with Nmap and look for open ports. I'll use a -SV flag to figure out if any of those services are vulnerable, and that's where I'm probably going to get into a network, not through the front door. Now let's talk about some other DNS attacks. And these aren't really DNS attacks as such, they're wireless attacks. The evil twin and the rogue access point attacks, I'll describe them now, but DNS can have a part in these. So, great exam question. What is an evil twin? What is a rogue access point? We have our friend having a cup of coffee, and they're at the coffee shop. Perky Coffee. And the password to the network is Perky. Excellent. They have their network. They have a laptop, they connect to the network, they're good to go. They're going out to the internet, life is good. But down here we have somebody who's not so kind. This is an evil twin. Now, as you can see, they have exactly the same SSID as the coffee shop. That makes them an evil twin. Now, if they just had an SSID that said free Wi-Fi, free airport Wi-Fi, Denver airport free Wi-Fi, coffee shop free Wi-Fi, if it didn't have exactly the same name as a known trusted network, it would just be called a rogue access point. It's inviting. Now, if our friend over here connects to the evil twin instead, what happens? All the traffic goes through this router. Now, the attacker is no idiot. He's going to then have another connection to the coffee shop and use their internet connection to go out to the world. And what we have now is a way of intercepting the traffic as it comes from our friend through the evil twin to the real coffee shop, to the internet, back again, back through the evil twin, and eventually back to our victim. Now, in this case, our victim does not even know they're using an evil twin because the traffic works fine. They make a request to the internet and they get the response back. Now, if you are not using secure protocols, if you're using HTTP, if you're using FTP, if you're using SMTP, port 25, if you're using POP and IMAP, these ports are 143 and for IMAP, and POP is, oh my goodness, I can't remember POP right at the top of my head, don't remember. These protocols are all in the clear. And in this case, our evil twin can see all the emails we're sending, can see all the web pages that we're going to. Not only can they see them, they can modify the requests and they can modify the responses. They can capture any passwords that you enter and see all the data coming back. And because they've got your credentials, they can log in as you later. So never use these unsecure protocols. Always use HTTPS. Always use secure SMTP and secure POP, or sometimes called POP secure, and secure IMAP. So this is the secure protocols you should be using. Supposing you are using secure protocols. In theory, the attacker cannot see your traffic and cannot modify your traffic. However, what happens when you join this network? This router gives you your IP address to use on this network. But not only does it give you your IP address, it gives you your DNS server that it wants you to use as well. So if you have, or the attacker has, a fake DNS server, either on the internet or connected to the router, it can happen that way too. If you've ever seen a Pineapple, it's a Wi-Fi device that is used for these kind of attacks. If the attacker has a fake DNS server, when you do a DNS request for Amazon.com, the attacker sees that and can send you back a fake IP address. And what do they have? Somewhere out here on the internet, they have a phishing Amazon.com website that looks just like Amazon.com. You enter your credentials and they've got them. So although they're not technically a DNS attack, DNS can be an attack as part of an evil twin or a rogue access point. That is why we always use a privacy VPN like NordVPN if we're at a coffee shop or we're at an airport or a hotel. The VPN provider like NordVPN, specifies the DNS service you should be using. It's one of theirs that they trust, and it encrypts all the traffic going through and coming back in a VPN tunnel to keep all the data secure against eavesdropping and modification. Always use a VPN. Now, one more attack I just wanted to mention because it's on exams. It's called a homograph attack. And a homograph attack is when you have a character in a domain name that isn't part of our normal ASCII character set. So we use UTF 127 or 256, Latin standard characters. A through Z, uppercase, lowercase, numbers and symbols. But the internet also uses an extended character set that Cyrillic letters, Chinese characters, all that kind of stuff. And some of those characters look just like our Latin characters. Now these are called confusables if to the human eye they look similar. If you look at google.com, if you notice that second O looks just a little bit different. If you replace one of the ASCII Latin character O's with a Cyrillic O, it looks almost the same, but it's different. So if there's a link that you click on and you inspect the link, you right click properties, look at the link, and it looks like google.com, and you don't notice that one of those characters is just a little bit different, when you click on that link or you copy and paste it into your browser's window, you're going to go to a fake website, because that domain, google.com, is registered to a separate IP address from the real Google, and it will have a different IP address, and it will have a fake web page for you to go to. It can be Amazon, it can be Walmart, it can be whatever you like. These confusables are becoming more and more popular with attackers. And then some certificate authorities will actually give you a certificate for that confusable domain name. Looks the same to the human eye. It's completely different when it's converted to ones and zeros. And some of the automated certification authorities will give you a domain certificate that matches that confusable domain. So you'll go to the website, you'll go to the web page, you'll get a nice padlock that shows it's secure, and it looks like there's a valid certificate there for google.com. Keep an eye out for that on the exams. So let's talk a little bit more about DKIM and SPF. From earlier in our series about DNS, we discussed this briefly. The DKIM and SPF records have to be entered manually by the owner of a domain into the name server of the person who sold them that domain. So for me, CyberIrishman.com, I have to go to GoDaddy and manually enter these DKIM and SPF details into the DNS records on the name servers of GoDaddy. Those details then get propagated out to the world so anybody can see them. What we're interested in here is under the TXT, the text records, and I'm going to enter my SPF details and my DKIM details. For instance, under SPF, I'm going to say, hey, include anything from zoho.com. If an email comes to you and it purports to come from CyberIrishman.com, when we look at the chain of servers that email has gone through to get to its destination, the very first server it should have left from should be one of the Zoho servers. That is our SPF. DKIM, inside DKIM, there is a public key that I have got from Zoho, my email provider. And I've entered this public key into the DNS records of my DNS entry at GoDaddy. I've just copied and pasted it in there. And this is the public key of the Zoho server that my email should leave from. Remember, our zone transfer records. This is what I get when I do a zone transfer, something like this. These are called the zone records. And under the text section, we have the SPF and we have the DKIM public key details that I, the owner of this domain, for instance, everreadyguides.com, I've gone to my registrar and entered that detail into my DNS records. So let's look at an email. This email has been received by Andrew at secureninja.com. It was sent by Andrew at CyberIrishman.com. It has got to the secureninja.com email server. It's been delivered. And what happens is the secureninja.com's email server, in this case it's run by Microsoft 365, they look at the headers. They also know it's coming from CyberIrishman.com. So it does a DKIM and an SPF check. It goes to the DNS records of CyberIrishman.com and it pulls down the DKIM and the SPF data and carries out its checks. And if the checks are good, the email is considered good and it's not marked as spam. So let's see in more detail how it all actually works. I have Andrew at cyberirishman.com and I have the receiver of an email, tom@gmail.com. Now for all this to work, I'm going to have to start and upload my SPF and DKIM details to my server. In this case, GoDaddy is the owner of my domain. So I'm going to go and I'm going to grab Zoho's public key. That's available to me because I have a Zoho email account. My email is handled by Zoho. I go into my account, I go through administration and I find the public key. And I'm going to go to the GoDaddy server and I'm going to upload that information to my DNS records. I'm going to put the SPF in. Hey, if you're going to get an email from me, it should come from a Zoho server. And if it's signed, it should have this public key. This public key should be able to decrypt the signature. Now what happens next is propagated out to the rest of the DNS system, including dns.google.com and all the other DNS servers on the internet. So they all have a copy of that record. But we remember from DNS, the source of authority is going to be one of the GoDaddy servers. It's going to be the top dog in the domain chain for CyberIrishman.com. So next, Andrew's going to go ahead and create an email. And it gets sent to the Zoho mail server for being sent onto the rest of the internet. And as it's leaving the server, it gets a digital signature. Zoho's private key is added and it creates a digital signature for that piece of email. And we have a signed piece of email that gets sent to its destination server, in this case the Gmail server. Now the Gmail server has received the email, it's signed, it's going to Tom at Gmail and it's from Andrew at cyberirishman.com and it takes a look at the headers. And it sees that the first server that email left from, because every email server in the chain has to stamp a header. And it says the first server I left from was mail1.zoho.com, one of the email servers at Zoho. So now the receiving server does its spam checks. It goes to any DNS server. It's using dns.google.com. and goes ahead and looks at the CyberIrishman records and goes and pulls down the public key for Zoho that's in the DKIM records and pulls down the SPF information as well that says it should come from zoho.com. Pulls it down. I have the public key. The Gmail server applies the public key it got from the DNS records to that digital signature. And if it decrypts okay and it looks good, we have a okay with the DKIM. It worked. It was properly signed. Looks like it came from a Zoho server. Well, then it goes and checks what is the first server it left from. And if that matches what's in the DNS records, that is an SPF check. This email is considered not spam. So just to show you those headers in a little bit more detail, here's the headers from the email I showed you earlier. And these are the actual headers, and it's telling me DKIM is a pass. And it's also telling me the SPF is a pass as well. And these are the headers in the email that the receiving email server is actually looking at. And you can see SPF, it came from this IP address. And when they've checked on that IP address, it belongs to Zoho. And here is the public key that we applied to the digital signature. And if it showed that it was good, it's good. And that's how SPF and DKIM actually work. Awesome, guys. Hopefully you enjoyed that little lecture. All content is copyright of the CyberIrishman. If you're interested in cybersecurity hacking or AI training, go ahead and visit cyberirishman.com and we'll set up a call. And if you're interested in more videos like this in cybersecurity or AI content, if you're interested in my travel vlogs, I travel to Vietnam, Singapore, Thailand, China, many trips to Japan. Those are all on my YouTube channel as well as Digital Nomad content. If you're interested in living in another country and working as a digital nomad, I go to these countries and I talk to recruiters and digital nomads and talk to them about their experiences and also the skills that are needed in those countries if you're interested in emigrating to those countries. Go ahead and find me on YouTube at CyberIrishman, and if you like the content, please like and subscribe, and even leave a comment. If there's something you want me to explain for your exam, go ahead and leave it in the comments and I'll do my best to make a video for you. Anyway guys, I'm the CyberIrishman. Thanks so much for joining me. Hopefully I see you again soon.